going to start with an NCERT numerical. First of all, I will tell you what is this numerical. In this numerical, a ball is dropped from a height of 90 meter on a floor. At each collision with the floor, the ball loses 1/10 of its speed. Plot the graph, speed time graph of its motion between t is equal to 2 second to t is equal to 12 second. हमने क्या किया? We took a ball. The ball is thrown from a distance of 90 meter above the floor. When the ball is dropped, it will strike the ground and it will bounce back. It says whenever the ball bounce the ground, the जो ball है, when it will touch the ground and again it rises up, और जब वो राइज करेगी तो अपनी 1/10 स्पीड वो लूज कर देगी. मीन्स आफ्टर ईच कोलिजन जो उस बॉल की न्यू स्पीड होगी दैट विल बी इक्वल टू 9/10 ऑफ इट्स प्रीवियस स्पीड, क्योंकि 1/10 स्पीड वो लॉस कर देगी. तो अगर हम 1/10 टोटल स्पीड है 1, उसमें से 1/10 हम सबट्रैक्ट कर देते हैं, वी गेट 9/10. So after each collision with the ground, the speed of the ball will be 9/10 of its previous speed. So क्वेश्चन समझ लग गया आपको. और आपको करना क्या है? You need to plot the graph, the speed time graph of the ball between the time interval 0 to 12 seconds. So we will start solving it. First of all, the height is above the ground. We have taken the ball is coming downward, so the displacement will be taken as positive, that is 90 meter. Initially the ball is thrown from u is equal to 0. The ball is coming in the downward direction, so the acceleration due to gravity is positive, that is 9.8 meter per second square. Let us take the final speed as v. First of all, we will calculate the time by using the second equation of motion, that is s is equal to ut plus half at square. You have to do the calculations yourself. When you will solve it, you will get the value of time period as 4.29 seconds. After that, after calculating the time, we will calculate the velocity of the ball before hitting the ground. Before hitting the ground, the velocity of the ball is 42.04 meter per second. This we have calculated from first equation of motion, that is v is equal to u plus at. Now we have to calculate the rebound velocity. अब rebound velocity क्या है? After striking the ground, जब बॉल दोबारा ऊपर आई तो उसकी जो वेलोसिटी होगी एट दैट टाइम इज नोन एज रीबाउंड वेलोसिटी. अब वो पहले ही आपको एक्सप्लेन किया है, दैट इज 9/10 ऑफ द प्रीवियस वेलोसिटी. प्रीवियस वेलोसिटी क्या थी? 42.04. इसका 9/10 निकालेंगे, इट विल कम आउट टू बी 37.84 मीटर पर सेकेंड. नाउ देन वी विल कैलकुलेट द टाइम बाय यूजिंग द फर्स्ट इक्वेशन ऑफ मोशन. इट विल कम आउट टू बी 3.86 सेकेंड. अब टोटल कितना टाइम हो गया? 8.15 सेकेंड. मतलब 8.15 सेकेंड में बॉल पहले ग्राउंड को हिट किया, देन इट राइजेस अप. Now again it will hit the ground. Then for the second rebound, the velocity will be 34.05 and the total time before the second rebound will be 8.15 plus 3.86, that is 12 second. So हमने जो graph plot करना है, it is only till the second rebound. This is the graph. The speed is taken on the y-axis while the time is taken on the x-axis. You can analyze this graph. If you have any problem in this graph or while plotting these terms in this graph, you can ask in the class. Now in the next question, a boy is standing on a stationary lift which is open from above. He throws a ball upward with the maximum speed he can, and that speed is 49 meter per second. We have to calculate the time in which the ball returns the ground. Now here a boy, एक boy है, he is standing in a lift, और जो lift है it is stationary, मतलब the lift is not moving and it is open from above and he throws a ball upward and after throwing the ball upward, we have to calculate the time in which it comes to the ground. Here the initial velocity is 49 meter per second. We have thrown the ball upward, so the acceleration due to gravity will be taken as negative, that is minus 9.8 meter per second square. And to calculate the time, we will use the first equation of motion, that is v is equal to u plus gt, and when you will do the calculations, you will get the value for the time period is 5 seconds. Here the final velocity will be 0. Now in this second part of this question, we have to use the relative velocity concept, and the relative velocity concept we will do after doing the scalar and vectors in the second chapter, because to calculate the magnitude of the relative velocity, we need to use the concept of vectors. So after doing the part scalar and vector of motion in a plane, we will do the concept of relative velocity, and then only we will solve the numericals of relative velocity. Okay students, that's all for today.